Hey folks, how's it going? It's Mr. Murray coming to you with a Do Now for Course 1 Honors for Friday, May 29th, 2020. And welcome to the end of week 10. You made it. All right, so in this little Do Now, I'm going to be doing another example of solving exponential equations. So remember, these are equations where the thing we're trying to solve for is up in the exponent. If you haven't taken a look at the materials that we've done this week regarding this concept, I would recommend that you do those before taking an attempt at this, because I think it'll make this a more meaningful activity for you. All right, when you're ready, please go ahead, pause the video, solve the equations, and then when you're ready, unpause, and you can see what I got. All right. So remember, the goal is it's basically a three-step process. First, we're gonna head on down to bases alone. So you need to get the base with the exponent that has the letter in it. You need to get that alone. Okay, so 2, you gotta rewrite the other side. So we're gonna rewrite the right hand side so that its base, right, we're gonna write it as an exponential expression, right, and then its base will be the same as the base on the left. Step 3 is going to be to bring down exponents, and we can do that because of the one-to-one rule. And step 4 is solve, okay? Because now it turns it into just solving within the exponent, okay? So I'm just going to move these around just so I can have a little bit more room. So the first one is 4p is 24. So is the base alone? Yes, it is, right? There's nothing to the left. There's nothing to the right. So I rewrite 64 as a power of 4, and it's 4 cubed. So 4 to the p is equal to 4 cubed. So I have two expressions. They're equal to each other. Their bases are the same. Therefore, by the one-to-one property, their exponents are also equal. Okay. Second one, here the base is not alone because I've got this -2. So I start by dividing by -2 to get the base alone. So I have 4 to the 4g minus 2 is equal to positive 4. All right, and now the base is alone. This is already rewritten as a power of 4, so I'm good there. So because these expressions are equal and the bases are the same, by the one-to-one property, their exponents are also the same. And that should not be a 4, my apologies. That should be a 1, because the exponent there is a 1. Here it's 4g minus 2. And now I just solve for g. So I add 2, 4g equals 3, and then I divide by 4, g equals 3 quarters. Testing my work, 3 quarters times 4 is 3. 3 minus 2 is 1. 4 to the 1 is 4. 4 times -2 is -8. All right, coming down to the last one here. And same idea. First, get your bases alone. So I'm going to divide by -4. So I've got 2 to the 2x minus 3 is equal to 4. Now the bases are alone. I'm going to rewrite the right-hand side as a power of 2 because that's the base here. Right? Because 4 is 2 squared. Now I have two equal expressions with the same base. So by the one-to-one property, their exponents must be equal. And now I solve for x by first adding 3 and then dividing by 2. So x equals 5 halves, or 2.5. Testing my work, 2.5 times 2 is 5. 5 minus 3 is 2. 2 squared is 4. 4 times -4 is -16. Okay, so hopefully you're able to get these right. Our answers are 3, 3 quarters, 2.5. All right, if you were able to get these correct, congratulations. Very, very good job. If not, go back and take a look at what you might need to work on. Please make sure that you do attend today's Hangout because that will have some important tips for how you'll do today's lesson. We are getting ready to wrap up exponentials and move on to our last unit of the year. So I'm really excited to show you that. But until next time, have a wonderful day.